Welcome to a crucial topic in modern software development, mastering test data generation. If you've ever spent countless hours manually crafting test data, or struggled to achieve comprehensive test coverage due to a lack of diverse and realistic datasets, then today's video is for you. We're diving deep into how generative AI can revolutionize your Java testing pipelines, specifically for JUnit and Selenium tests. Imagine a world where your test data isn't just sufficient, but rich, varied, and perfectly tailored to uncover even the most subtle bugs. That world is closer than you think, thanks to GenAI. Stay tuned, because by the end of this tutorial, you'll understand the core concepts, benefits, and practical, conceptual, implementation of using AI to generate sophisticated test data for your Java projects. Let's unlock the power of intelligent test data together. Scene 1, the agony of manual test data generation. Alright, let's face it. For every software engineer, the phrase, test data generation, often brings a slight cringe. It's typically a manual, tedious, and time-consuming process. You create a few user profiles, some order details, maybe a handful of edge cases. But what inevitably happens? Your tests become biased towards the data you thought of, missing crucial real-world scenarios. This leads to limited diversity, unrealistic patterns, and ultimately, an incomplete test suite. Manual data creation is a bottleneck that restricts your ability to thoroughly test complex applications, leaving hidden bugs lurking in the shadows, waiting for production. It's a pain point we've all felt, hindering our pursuit of robust and reliable software. But what if there was a better way, a smarter way to feed your tests exactly what they need? Scene 2, enter generative AI, your new test data engine. This is where generative AI steps in as a game-changer. Imagine having an intelligent assistant that can conjure up vast quantities of diverse, realistic, and context-aware test data on demand. That's the essence of GenAI-driven test data generation. Instead of painstakingly typing out data, you simply describe what you need using natural language prompts. For example, you could prompt the AI, generate 10 user profiles for an e-commerce platform, ensuring some users are under 18 and some over 65, including names, emails, and ages. The GenAI model processes this prompt and returns structured data, typically in JSON format, ready for your tests. This approach doesn't just save time, it fundamentally enhances the quality and breadth of your testing efforts. It allows you to explore an almost infinite range of scenarios, ensuring your application can handle anything the real world throws at it. Scene 3, the conceptual architecture, how it works. So, how does this magic happen? Let's look at the conceptual architecture behind it. At its core, the process involves three main stages. First, you formulate a natural language prompt, describing the specific test data you require. This prompt is then sent to a generative AI model, like OpenAI's GPT or Google's Gemini, via their API. The GenAI model, leveraging its vast training data and understanding of context, processes your request and generates structured data, most commonly in JSON format. Finally, your Java application parses this JSON output and seamlessly integrates it into your JUnit unit tests or Selenium end-to-end automation tests. This pipeline allows for dynamic data generation, making your tests more adaptable and powerful than ever before. In our conceptual project, we've simulated this interaction to demonstrate the flow. Scene 4. Simulating GenAI interaction with GenAI-Data-Generator.java. In our demonstration project, GenAI-Data-Generator.java is the cornerstone, simulating the interaction with a real generative AI model. While a production system would involve actual API calls to services like OpenAI or Google Gemini, complete with API keys and detailed JSON schemas for output formatting. Our example programmatically generates diverse data based on the concept of a prompt. This allows us to illustrate the type of varied and intelligent output a true GenAI could provide. Think of it as a sophisticated mock. It takes a textual prompt and a desired count, then produces a list of user objects, mimicking how a real AI would parse your request and return structured information. This class is designed to show you the potential and the integration point, abstracting away the complexities of direct AI API communication for clarity in this tutorial. Scene 5, the data backbone, user model and user service. Central to our conceptual application are two fundamental components, the user model and the user service. The user.java class is a simple plain old Java object, or POJO, representing a typical user entity with fields like first name, last name, email, age, and country. This is precisely the kind of structured data we want our generative AI to produce. Complementing this, userService.java is a basic service layer that manages these user objects. In a real-world application, this service would interact with a database, but for our demonstration, it uses an in-memory map to store and retrieve users. This setup provides a clear, concise target for our tests, allowing us to focus on how the GenAI-generated data seamlessly flows into and validates the core business logic of our user service, making our testing approach highly realistic. Scene 6, JUnit Testing Enhanced, userServiceTest.java and Parameterized Tests. Now, let's talk about the heart of our testing strategy, userServiceTest.java. This JUnit 5 test class brilliantly showcases how GenAI-driven test data integrates into your unit tests. We leverage JUnit's parameterized test and method source annotations, which allow us to run the same test method multiple times with different sets of input data. Imagine creating methods like diverse user data, minor user data, and senior user data. Each of these methods uses our GenAI data generator with a distinct natural language prompt to fetch tailored user lists. For instance, minor user data prompts the GenAI to generate users under 18. A critical step here, and a best practice, is to add assertions right within these data generation methods to validate that the GenAI indeed produced data matching your prompt's criteria, like assert true, user.getAge, less than 18. This ensures the quality and relevance of your AI-generated datasets before they even hit your actual test logic. Scene 7, Driving Diversity with ShouldRegisterDiverse Users. Let's put this into action with our ShouldRegisterDiverse Users test method within userServiceTest.java. This test, annotated with a parameterized test and drawing data from diverse user data, perfectly illustrates how GenAI significantly boosts test coverage. Instead of testing with one or two hard-coded users, this single test method will execute for each of the 10 diverse user profiles generated by our GenAI simulator. Each user comes with a unique ID, name, email, age, and country, exposing your user service to a wide array of inputs. This ensures that the user registration logic is robust enough to handle variations in real-world data, drastically reducing the chances of unforeseen issues in production. The sheer volume and variety of data generated on the fly mean your tests are more thorough, revealing problems that simple, manually created data sets would never uncover. Scene 8, Targeting Edge Cases with AI Precision. Beyond broad diversity, generative AI truly shines in its ability to pinpoint and generate data for specific edge cases, which are notoriously difficult to create manually. Consider our should handle minor users and should update senior users tests. For should handle minor users, we prompt the GenAI for users explicitly under 18. Our conceptual user service might then throw an illegal argument exception if it encounters such a user, simulating an age restriction. The GenAI's ability to generate these specific profiles allows you to rigorously test your application's validation and error handling logic for cryptography.